So number 13, this is a question on matrices form 3. So you're given a matrix P and Q there, and then R is equals to 20. This P power -1 is the inverse of P plus Q. So determine matrix R. So first of all, maybe you can find them the inverse of P. So for you to get the inverse of P, the first thing is you get the determinant. And the determinant is the product of the leading diagonal minus the product of the secondary diagonal. So the leading diagonal is this one. It's known as the leading diagonal. So the product, it is 4 times -1, so that is -4. And then you're going to subtract the product of the secondary diagonal. So this one is known as the secondary. So that is 2 times -7, so that is -14. So that is the same as -4 plus 14. So you're going to get 10. After that, now the inverse will be 1 over the determinant. So it is 1/10, and then brackets. So you're going to swap the leading diagonal. So where you have 4, you put -1, and where you have -1, you put 4. So this one will be -1, and then here will be 4. And then you change the sign of the secondary diagonal. So if it was negative, it will become positive, and if it was positive sign, becomes negative sign. But then you maintain the position of the elements. The elements are these numbers, they're known as elements. So it will be 7, -2. Now, of course, you can decide to multiply by 1/10, or can leave it like that, because outside it is 20 times the inverse of P. So you can leave it because this is going to divide by 20. You're going to have 20, and then you have that bracket. So we have 1/10. And then now the matrix, so that is -1, -2, 7, 4. So you multiply. So by 10, 1, by 10, 2. So we're going to have 2 into brackets, -1, -2, 7, 4. So this one will give you, so just multiply, so that is -2, -4, 14, 8. Now, turn out to add Q, so that is -2 -4, 14, 8, plus Q, it is -1, 5, 6, -3. So it is compatible. Before adding, you must confirm if it is compatible. Now, for addition of matrices, for you to add, then it means that they must have the same order. The two matrices or 2 or more matrices must have the same order. So these are 2 by 2. You're going to add a 2 by 2, so it is compatible. Now, in addition, you add elements by elements. For example, an element in row 1, column 1, you add it to an element in row 1, column 1. So -2, you're going to add it to -1. -2, you're going to add it to -1, and then so on and so forth. So now you're going now to add, and this is how you add it. So put that bracket. So you're going to have -2 -1, because it is -2 plus -1, and then -4 plus 5, and then we have 14 plus 6, and 8 minus 3, and then close it. So going to have your answer as -3, and then this is 1, and then 20, and then this one is 5. Now that is your matrix R. For number 14, now this one is a statistics 1 form 2. So you have the number of children per family was recorded from that families. The data recorded is shown here. So represent the data in a frequency distribution table. Now this data is known as raw data. It is raw data because it is not arranged. It is a raw data. So we want to get the information from this raw data so that now we'll be able now to draw the frequency distribution table. So just need to draw a table. You have a table, maybe. Okay. You have a table like that. So in the now here you have number of children, and then number of family, or rather you can have tallying. You can have that one for tallying, and then number of family. Now remember this one, the number of children represents your x, and this one, it is the frequency. Yes. Now you see from here you have the least number is 0 and the greatest or the largest number is 7. So we need to start with 0, and then you confirm if you have 1. So you have it because you have it here. So the second one will going to have 1, followed by 2. I think we have up to 7. So there's no number, so it is equal. So that is 2, 3, 2, 3, 4, 5. But the space is not enough. Maybe you can draw it down here. But then you show the examiner that table is for part A. You can draw it in this space, in the space down here, but then you need to note it. You write maybe question 14, number A, and then you draw the table because of this space. I think it is small. So you have 6 and 7. So tallying, come here now. The family that had no child is this one. So you put a stroke, and here you write 1. Family that had 1 child, it is 1, 2, 3. Yes, 3. So here you put 3 strokes, 1, 2, 3, and then here you write 3. That had 2, 1, 2, 3, 4, 5, 6, 7, 8. Put 8 strokes, so that is 1, 2, 3, 4, 5, 6, 7, 8. So here you have 8. And then 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10. 4, you have 1, 2, 3, 3. So this is 1, 2, 3. So you write 3, and then 5. 5, you have 1, 2. So you have 1, 2. So here is 2. And then 6, 1, 2. So we have 2, 1, 2. So here is 2. And then 7, 1. So 1 stroke, and then here is 1. So you have to confirm that this one is total to 30. The total of this is 30, the number of families. If it is not, then you have to repeat to check if maybe there's a number you skipped. So confirm. Yes, it is 30, so it is fine. So now this one now to be a summation, because when you look at, okay, for part A, now this one is the frequency distribution table. And then for part B, calculate the number of children per family. So that one now is the mean. And you know the mean, it is summation fx over summation f. That is the mean. So maybe here you can have summation f, that is 30. And then maybe you can have fx. Just need to multiply 0 times 1, going to get 0. 3, that is 1 times 3. Then this one is 16. This one is 30. This one is 12, 10, 12, 7. So you can just add that column there so that you have summation fx. Or simply you can just do this: 0 times 1 plus 1 times 3 plus 2 times 8 plus 3 times 10 plus 4 times 3 plus 5 times 2 plus 6 times 2 plus 7 times 1, and then all over you divide by summation f. You divide by that, or can do this. So I think you're going to get, you add all this. So here it is 90. So going to get 90 over 3, 90 over 30. So going to get the answer as 3. Now, for this second part, you have it here. Number 15. The equation of a curve is given by y is equals to 3x squared minus 2x. Determine the equation of the normal to the curve at x is equals to 2. Now this one is a topic in form 4, known as calculus, and a subtopic known as differentiation. Now, the equation of normal. Now, remember that if you have a curve, this one is your curve, and you want to find the gradient of that curve at x is equals to 2. Of course, you have a Cartesian plane. You have a Cartesian plane here. So we have a topic in form 3 known as graphical method. For that one, now we want to find the gradient at x is equals to 2. So here you have x is equals to 2. So you're going to draw that dotted line, and then you're going to draw a tangent at that point, a straight line, and then you find the equation of that tangent. It will give you, no, you find the gradient for the tangent. It will give you the gradient of that curve at x is equals to 2. But now in form 4, you're supposed not to use a formula. There's a way you're supposed now to find the gradient of a tangent at a particular point. And that is differentiation. Now here in form 2, in form 3, you're going to draw a tangent, and then you're going to find the gradient of this tangent. Now, we have another line known as normal. And this line, it is perpendicular to the tangent at the point of contact with the curve. So at x is equals to 2, we have another line that is perpendicular to a tangent. And that line is known as the normal. This one. It is perpendicular to that tangent. So, and in form 2, under equation of a line, we are told that when you have two lines that are perpendicular to each other, the product of their gradient is equals to -1. Is the same, the answer is -1. So if you have the gradient of this tangent, let me call it M1, and you want to find the gradient of a normal, the M2, then it means that when you take M1 times M2, it must give you -1. So first of all, you need to get the gradient of a tangent. So from this one, from this equation 1 is equals to 3x squared minus 2x. We differentiate to get what is known as the gradient function, dy over dx. So this one will be 6x minus 2. Just multiply 2 times 3, and then you reduce this one by 1. So up here we have x power 1. So it is 1 times 2. It is 2, and then you reduce this one by 1. So it would be x power 0. And then any number raised to 0 is 1. Now this one is known as the gradient function. So at x is equals to 2. Now we're going now to get the gradient of a tangent at x is equals to 2, substitute. We're going to have dy over dx is equals to 12 minus 2. We're going to get it as 10. Now this 10 is the gradient of a tangent at x is equal to 2. Now, because now they're asking about the equation of normal, so you need now to get the gradient of normal. So gradient of normal. And we have that 10 m2 is equals to -1. So meaning that m2 is equals to -1 over 10. And you cannot find the equation of a line if you don't have the coordinates. So we need now to get the coordinate at this point. When x is equals to 2, what is the value of y? So that now we get the coordinates. And because now we have the gradient here, you can now find the equation. So at x is equals to 2. Now what is the value of y? To substitute in the original equation. So y will be equal to 3 times 2 squared minus 2 times 2. Now this one we're going to get, it is that is 4, so that is 12 minus 4. So we're going to get the value of y is 8. So meaning that the coordinates at this point, it is 2, 8. 2, 8. So you can now find the equation. So you have a point 2, 8, and you have the gradient as -1 over 10. So you can now find the equation y minus 8 over x minus 2 is equals to -1 over 10, cross multiplying. So that will be 10y minus 18 is equals to minus x plus 2. You can have, because they did not specify in which form to leave the equation, you can collect the like terms. So you can have 10y is equals to minus x plus 82. Yes, you can have that one as the answer, or you can write it in the form y is equals to mx plus c. Yes. Number 16. You're told on the following Cartesian plane, provided solve the simultaneous equation. Now this is a question in form 1, solving the simultaneous equation. using graphical method. Now, we have these two questions. Now, meaning that you need tables of values to find coordinate values. This one it is a straight line. So you just need a small table, maybe for the easy equation. Y is equals to 4x plus 2. You need a small table. Maybe you need to get two values. So you have x and y. Now this question is tricky because you need to find the value of x that you're going to choose must be divisible by 3, so that like we and because you need 2 points, maybe you can have when x is equal to 0 and when x is equal to 6, when x is equal to negative 3, negative 6, provided the value of x that you're going to choose, it is divisible by 3, then it will be easier for you. So when x is equal to 0, find that y. And when x is equal to 3, so that is 4 over 3 times 3, so that is also 0. You can also try when x is equal to 3 and x is equal to 9, when x is equal to 12. But of course, you don't need to choose a number which is more than 6 because of this graph here. You also need to choose the values that ranges from -4 to 6 for the values of x. And that number must be divisible by either 0 or a number that is divisible by. You can choose -3, you can choose 0, you can choose 3, and you can choose 6. So that now you're able now to plot it. So here you're going to plot point that is 0, 2 and 3, 2. So you come here, you plot it, 0, 2, it is there, and 3, 6 is there. Now you draw a straight line passing through the points. Sorry for that. You're going to take your ruler. You're going to draw a straight line. And then you write the equation of that line. Don't forget to write the equation. And then I'll come out to the second equation. Now, for the second equation, you have 3y is equal to x minus 3. So this one, you need to choose a number that is divisible by 3 because of, or take -3 to the other side. So that now you can choose any value. But if it is like this, then, okay, maybe you can still have x is equals to 3y plus 3. And then now you draw that table, just need two values. So you have x and y. Of course, you can choose, and then for the also this one, you need to choose the values of x. Okay, or you can choose the values of y because you need to find x. You can choose the values of y according to this second equation. Just choose the values of y, and the values of y must be from -3 to 6. So maybe you can choose when y is substitute, you're going to find the value of x when y is equals to 1. Going to find this one is equal to 6, because also the values of x that we're going to get here, it must be between -4 and 6, so that you're able now to plot. Maybe when you choose, for example, if you choose y is equal to 2, you're going to find a value which is 9, and you cannot be able to show it here. So you choose a small value, maybe -1 can also have -2, because that will be -6 plus 3 will still work. So come and plot it. So you have 0, 3. No, you have, you're going to plot 3, 0 and 6, 1. You're going to plot 3, 0, 3, 0. 3, 0 is here. And 6, 1. You also join the 2 points using a straight line, and it must intersect the other line. It must intersect. I think the solution for this one was -3, negative. You can draw it in your graph book. You get the solution here, the point where the 2 lines intersect. And that will now would be the solution. Now you come and write x is equals to the coordinates, the x coordinate here. So if it is this point, so you write x is equals to -3, and then y is equals to -2. So you have to write that answer. X is equals to -3, x is equals to -2.